AB Calculus, section 4.3, page 4. We are going to be sketching some graphs today. We're looking at sketching a graph when f of x is continuous and f prime of x is greater than 0 if x is less than c, and a couple other conditions here. Let's just kind of look at this. I've given you information about f prime and information about f double prime. What does that tell you about the graph of f of x? And what it tells you is if f prime is greater than 0 when x is less than c, f prime positive tells us that f of x is increasing. If f prime is negative, less than 0, that tells us that f of x is decreasing. F double prime greater than 0 tells us that f of x is concave up, and f double prime greater than 0 over here again tells us that f of x is concave up. Okay, now let's just take a look at some basic pieces of information, just some general ideas about graphs. A graph that's shaped like this is increasing and concave up. A graph shaped like this is still increasing, but it is concave down. A graph like this is decreasing, concave up, and this way is decreasing, concave down. All right, so now we have to put all this information together. Everything is around some point C. I have no idea where C is in relationship to the y-axis, so I won't even identify where that y-axis is. There's just some, probably the x-axis here with some C value identified. And when x is less than C, so to the left side of C, the function has to be increasing, which means it has to be one of these guys, increasing, and then right here, also on the left side of C, we have to be concave up. So increasing and concave up on the left side of C has to look like this piece. So increasing, concave up on the left side of C. On the right side of C, function is decreasing and also concave up. So decreasing, concave up, that's this piece right here. Decreasing and concave up, and that looks like that. Might be a cusp, might be a corner, we're not really sure. I've drawn it kind of cusp-ish, but I could have drawn it more like a corner. We don't know anymore. Might be a corner, might be a cusp. Not really sure. All right, let's look at number 6 down here. Again, we're going to sketch a graph using this given information. First, f of x is continuous, and a couple other things here. Let's just start identifying them as in terms of how they relate to f of x. If f prime at some value c is equal to 0, that tells you that we have a horizontal tangent on f of x at x equals c. F prime greater than 0 when x is less than c. That says that f of x is increasing. And f double prime greater than 0 if x is greater than c. That tells concave up. And that's all the information we have. So again, let's go ahead and we're going to sketch this. Let's identify some spot C. All right, now starting at this spot C, we have a horizontal tangent. In terms of height, I don't know, so I'm just going to arbitrarily put in a little baby horizontal tangent here at C. prior to C, so when we're to the left side of C, the graph has to be increasing. Now there's our two choices for increasing up here. Increasing this way or increasing this way. Which one of those is going to lead into this nice horizontal tangent? That would have to be the increasing concave down. So we're going to have to see something like that. On the other side, f double prime is greater than 0 when x is greater than c. We have to be concave up. There are two concave up possibilities, and it's those two right there that I kept uncovered. And which one of those concave up pieces, because it's got to be over here, so the left side of that concave up piece has to fit over here. And it's got to be this increasing concave up one, so we have something like that. All right. Now, moving on, we have another test called the second derivative test. So we know about the first derivative test. That talks about f prime being greater than 0 or f prime being less than 0. The second derivative test is the following. It says if c is a critical number of a function where f prime of c is equal to 0 and f double prime exists for some interval containing c. All right, let's just clean this bit up a bit. If c is a critical number, all right, a critical number is from f prime only. It's not from f double prime, it's only from f prime. And it's the critical number where the derivative was equal to 0. Where we had a horizontal tangent. All right, now, so we have a critical number from f prime and we have a horizontal tangent there. If f double prime is less than 0, then f has a relative maximum at x equals c. All right, let's think about this. F double prime less than 0, that means concave down. So when we sketch a graph of this one, kind of what it's going to look like. Some spot C with a horizontal tangent from that critical number in the horizontal tangent, and at C, where the graph is concave down, well, then that point C has to be a relative maximum. Must be a relative maximum. Likewise, if we look at this piece, if f double prime is greater than 0, that means that f is concave up. All right, again, sketching this one. Some spot C, horizontal tangent, and at this point C, the function is concave up. Something like that. Then that point C has to be a relative minimum. Now, please be very careful. Many students incorrectly believe that the second derivative test refers to concavity and points of inflection. It does not. Does not. The second derivative test refers to extrema, maxes and mins, just like the first derivative test. Both identify the location of extreme values, but by using different derivatives. Please read this again and make sure you don't get caught up in that second derivative test.